And we have
Sorry, Dr. Jehani, would you please go ahead? Sorry, it was my bad. Go ahead, please, one more time. Sorry.
Sure. From the beginning?
Yes.
Okay, go back one slide then. Hello, everyone. Welcome to our webinar series. Today's Occupant Protection Technologies and also Distracted Driving after this. This is done by Morgan State University. And also we have been working with Maryland Highway Safety Office, M.MVA MHSO. Can you go to the next slide, please? The presenters are myself, Mansoura Jehani, the director of the National Transportation Center and also Urban Mobility and Equity Center at Morgan State University. And
hello, everyone. My name is Ezaz Sadegh-Vaziri, and I am postdoctoral research associate and also an adjunct faculty at Morgan State University.
Hello, everyone. Hello, everyone. My name is... Okay, let's try again. Hello, everyone. My name is Ramina Javid. I'm a PhD student at Morgan State University, Department of Transportation and Urban Infrastructure.
Next slide, please. So our contact information is on that slide. We are National Transportation Center, and our website, Twitter and Facebook, Instagram, and LinkedIn, all of those you can see them here. And so what we are going to talk about today, we're going to go over introduction, problem statement, and we're going to look at the review and classification of occupant protection technologies. We categorize them into two categories of active safety technology and passive safety technologies. At the end, we're going to give a summary of our findings, and it's going to end with Q&A. So I give it to Dr. Ezaz to do the introduction.
Okay, hello, everyone. Thank you very much, Dr. Jehani. So today, in today's webinar, Dr. Jehani, me, and Ramina, we are going to talk about occupant protection technologies. As we know that based on Dr. Jehani's mentioned, we are going to categorize everything into two big categories. Basically, the definition of occupant technologies is that any devices that designed for specific purposes for reducing the occurrence or the severity of the injuries and crashes. It can be anything such as the one that every one of us are very aware of them, such as seatbelts, such as airbags, or very advanced ones that we can see them in a very advanced vehicles, such as the new models of Mercedes or Teslas. We are trying to bring the new technologies that help all of us to protect ourselves. First, it's in trying to kind of reducing the possibility of having any crash as active technologies. And also second, what if a crash happens? So we want to get familiar with technologies that gonna help us when we get in the crash. And we call them as a passive safety technologies. And so the importance of it is that anytime that any crash happens, it's just a matter of seconds, or even sometimes the frictions of a second. So we would learn to be very aware of them. And also we want to make sure that we get protected from any possible crashes in order to decrease the chance of getting into any crash. And also, if by any chance we got into the crash, we want to decrease the severity of the crash. So these are our main goal, to get familiar with new technologies. Actually, the main issue is that right now we have lots of technologies that are very useful. They are very advanced. They have been proved. They have been through the different tests, and they're working very well. However, lots of drivers are not fully aware of them. So if we do not, if the people are not very aware of all possible technologies that can save people's lives, so then they're gonna be useless. So the main goal of us then is gonna be educating people about all technologies that can first avoid us from getting into any crashes. Second, save our lives if we get into crash. So the main goal of this project is to educating people about, the main goal of this webinar is to educate people about different technologies that can protect occupants. Okay, so we classify them. Let's just go one more time to all the classification of the occupant protection technologies. Basically, they are falling into two big categories that we are going through to bottom up each one of them today, and we'll learn lots of new things. The first category is active safety technologies. These technologies are avoiding drivers to get into crashes. It means that they're trying to save you as much as possible, make sure that you are in the lane, make sure that you are doing safe, you're driving safe. And these are they're called active safety technologies. And also we have passive safety technologies. These are the ones that if by any chance you are in the crash, they're gonna save your life or at least decrease the severity of injuries. So today, Ramina is going to talk about the first part, and then I will go for the second part. Now I'm handing it to Ramina, please.
Thank you, Dr. Azaz. So first, I'm going to talk about active safety technologies. Okay, so as Dr. Azaz said, active safety refers to all those safety technologies that are aimed to avoid a crash in the first place. So active safety in a vehicle aims to avoid crashes rather than protecting occupant from impact during a crash. The first technology that we are going to talk about is lane departure warning systems. So lane departure warning systems are warnings that the technology works the way that the vehicle warns the driver if it's drifting near or over the lane marking and the driver must act by steering the vehicle back to the middle of the lane. Also, there is no lane. If there is no lane marking, this feature does not work. So one of the subsystem of LDW are lane keeping assists. So lane keeping assist is like lane departure warning systems. However, it helps the driver to stay in the right lane by steering the car for up to 40 seconds. So this is useful if the driver drift the vehicle too far. So the vehicle then steers itself away back to the lane marking. The next technology is blind spot detection. So blind spot detection technology and lane departure warning that we talked about in the previous slide are often bundled in a package together. So this system actively monitors the blind spot over the shoulder and alerts the driver with a warning light when a threat is detected. It warns the driver when a vehicle approaches quickly into the driver's blind area. The next technologies are head-up displays. And so we have different types of head-up display that I'm going to talk about in the next slides. So generally, head-up displays is a device that projects an image directly under the driver's line of sight. onto the vehicle's windshield or a panel. So it delivers a variety of information without requiring the drivers to look away from the road. So as I told you, there are different types of head-up display. So the one that you're seeing right now is in-car head-up display. So in-car head-up display is provided by a manufacturer, and it's like a built-in technology. So the video that you are seeing right now is a new Mercedes S-Class 2021 head-up display, which is had with augmented reality. The next one is head-up display apps. So several developers develop a head-up display application. If the driver wish to add a head-up display, like if he's on a budget. So this app produced the picture reflected off the vehicle's windshield in the same way as the built-in head-up display does. So the driver can simply open the app and place his or her phone on the dashboard near the windshield. The next type of head-up displays are third-party head-up displays. So dedicated head-up display systems are available for several aftermarket providers. These are little boxes that could be installed to the dashboard of the vehicle. In addition, they project a picture onto the windshield, and they may be used in many vehicles, and they can plug into the car. The next technology that we are going to talk about is Adaptive Front Lighting System, or AFS. So AFS improves light distribution from the headlights based on driving conditions. The device directs the low beams headlights in the direction the driver desires to travel based on vehicle speed and steering inputs. As you can see here, it can be changed throughout the road. The next one is high beam control, or HBC. So high beam control is generally combined with adaptive front lighting system. During night, it detects incoming and preceding vehicles and automatically shift between high and low lights, making it kind of easier for the driver to see the threats. Okay, the next one is adaptive LED headlights. So adaptive LED headlights are efficient than conventional headlights, and the standard LED headlights have no adaptive function. So the lighting will not be adapted by on vehicle's speed, the road configuration, and incoming traffic. However, adaptive LED headlights actively adjust themselves based on road conditions, approaching traffic, and vehicle speed. The next one is Rear Vehicle Monitoring System, or RVM. So RVM measures the distance between a vehicle approaching from behind or in neighboring lanes. If there is a risk of crash when changing lanes, it alerts the driver with an alarm and a warning signal. The next one is PreCollision System. So PreCollision System is the state-of-the-art safety feature by Toyota, and can detect objects in the driver path and alert them when it's time to brake. Basically, it uses a front-facing camera and laser to kind of detects the objects. So it may even autonomously bring the vehicle to a complete stop if it's necessary. The next system that we are going to talk about are collision warning avoidance systems. So we have different types of collision warning avoidance systems. So basically, they are known as a driver assistance system, and they are a safety technology that are developed to avoid or reduce the severity of a crash in seconds before it happens. So once a collision has been identified, these systems can inform the driver by sound or light to assist the driver to avoid a crash. As I said before, we have different types of collision avoidance systems. So one of them is a forward collision warning system. So this technology is a safety device that keeps track of a vehicle's speed, the speed of the vehicle in front of it, and the distance between these two vehicles. So basically, this technology will warn the driver if the driver gets too close to the speed of the rear vehicle, but it will not apply the brakes automatically. The next type of collision warning avoidance systems are pedestrian detection systems. So pedestrians and cyclists are accounting for approximately a quarter of all fatalities on the road. So a pedestrian detection system employs sensors to detect human movement on the road, such as cyclists or jaywalkers, with the hopes of assisting drivers in spotting a movement before it's too late. The other one is brake assist. So most road crashes might have been prevented according to studies conducted by vehicle manufacturers if the driver had hit the brakes promptly and with more force after realizing the danger. Therefore, vehicle manufacturers utilize a brake assist, a technology to help drivers in such panic situation. So basically, brake assist increases braking pressure in an emergency. The other one is anti-lock braking system. So anti-lock braking system is also known as the anti-skid braking system. So this technology prevents any wheel lock when the driver suddenly applies the brake to a high-speed vehicle. Therefore, the driver will not lose his control after the vehicle and kind of prevent a crash this way. We have emergency stop signal system also as an active safety technology. So this technology is intended to communicate the message of emergency brake stop to the vehicle following closely behind them. So if the driver unexpectedly stop while driving at a fast speed, the emergency signal system triggers the warning lights to flash. So this will help to avoid crashes by alerting oncoming traffic that the vehicle is braking hard. And also to assist minimize rear end crashes, the danger light switch to a regular flashing speed when the vehicle comes to a complete stop. Electronic stability control, or ESC, are a technology. It's an intelligent safety system that can anticipate the driver's driving intention. It aids the driver in maintaining wheel trajectory, and it's kind of the main goal is to improve vehicle stability. So when compared to ABS system, this technology offers additional benefits. This is due to the fact that it's capable of predicting the vehicle driving's behavior. We also have intelligent speed adaptation. So this technology helps drivers stay within the speed limit. So a worldwide navigation satellite system such as GPS is linked to a speed zone database, allowing the vehicle to know its position as well as the speed restriction on that particular route. So if the vehicle exceeds the speed limit, this technology offers visible feedback to the driver. Adaptive or autonomous cruise control, or ACC, is the next generation of cruise control. So the driver can use cruise control to automatically maintain the desired speed when traveling at a steady pace. This technique is useful and it's kind of considerably minimize the driver fatigue. One of the subsystems of ACC are traffic jam assists, and they can take over some steering functions in in a road, and as long as traffic is following slowly, they can be help for the drivers. It also orients itself to lane markers, roadside buildings, and other vehicles on the road by making a moderate steering motion within system restrictions. Tire pressure monitoring systems are designed to alert the driver if one or more of the tires are considerably underinflated, potentially resulting in dangerous driving conditions. So this system it will indicate a yellow sign in the shape of a tire cross-section with an exclamation point that glow on the dashboard panel. So we have a driver monitoring system, also as an active safety technology. And basically there are a single camera and they track the driver's face expression. And they will warn the driver when they take their eyes off the road, and like if they look at their phone or when they're drowsy, it will alert the drivers. The next one are night vision systems, which can improve a vehicle driver's sight in dark. They show the road ahead on the board screen of the car, and at night or in low visibility circumstances, the technology enhances the range of vision. Another one is rear cross traffic alert. So this technology allows the vehicle to reverse out of parking lots and driveways with more accuracy. Rear cross traffic alert is intended to assist the driver in, as I said before, breaking out of space when the driver may not be able to notice incoming traffic. The system looks for cars approaching from the right or left in two regions behind the driver. The other one is road sign or vulnerable road user detection. So vehicles should be able to recognize numerous traffic signs, traffic lights, and other objects, as well as pedestrians on the road as they become semi-autonomous. So identifying all of this will ensure that the vehicle take the required precautions and follow all traffic regulations. So this is what this technology will do. Another one is turn and crossing assist. Turn assist it works the way that monitor the vehicle when the driver activates the turn signals. The system can intervene by applying the brakes to avoid colliding with an incoming vehicle when turning left or right. And also crossing assist detects dangerous cross traffic ahead of the vehicle and alerts the driver visually or audibly. If the driver ignores the warning and continue to go into the incoming traffic, this technology will apply the brakes to stop the vehicle. Another one is hold assist. So when the vehicle is on the regular inclines and descent of street traffic, this feature allows for simple dry offs and prevents the vehicle from rolling. When the vehicle is stopped for a longer amount of time, the system automatically switches to the electromechanical parking brake. So this guarantees that the vehicle will remain still even if the parking brake is not engaged. We also have exit warnings. So exit warning increases traffic safety in cities. So this technology alerts passengers not to open the doors if the vehicle has come to a halt or other vehicles or bikers are coming from behind them. So the exit warning uses LED lights in the door panels, as you can see in the video. The LED flicker and become red in potentially dangerous conditions. We also have 360 degrees cameras. So these cameras can scan the nearby area and display any obstacle they find. So drivers may select from a variety of viewpoints that make parking and maneuvering easier. And also they have a front and back views. It also almost is a 180 degrees and provide a superior vision while exiting from a narrow spot and entrances or complex crossings. We also have rear occupant alert systems. So this device uses an ultrasonic sensor to monitor the back seat of the car, which aids the detection of children's movement. So the system initially warns the drivers to check the back seat before departing the car. And after the driver exits the car, the system will sound the horn, flash the light, or even send a link warning to driver's smartphone if it detects movement in the back seat. So these were all active safety technologies. And now I'm going to hand it to Dr. Ezas to talk about passive safety technologies.
Thank you so much, Ramina. So now we have learned so far a lot about active safety technologies, the technologies that can protect occupants from getting into the crash. So now let's just get ourselves a little into the technologies that can save us once we are in the crash, and what kind of technologies the automobile industry has provided and equipped their vehicles with. So the very first one is gonna be, as we said, that the passive safety technologies are the features that basically help the drivers from, reducing the severity and level of injuries when the occupants get into the crash. And historically, the drivers and the front seat are occupants that have been his highest priority because they account for the greatest number of casualties. And but little by little, the other participants, the other occupants also understood. It was understood that other participants are very important. So airbag first emerged as occupant protection devices in early 1970s. They were initially designed as an alternative to seat belt, but are not used and supplementary restraint system to seat belt with the primary aims of reducing the likelihood of occupants contacting rigid in its internal structures in the vehicle. And as you can see, for example, here in this slide, traditionally, we just used to have airbags for the front seats. But now we can see that there are plenty of the new technologies specifically for the people in the back seats, specifically the Mercedes-Benz S-Class. They're working a lot on the back seat airbag. This is a very new technology and very interesting. And front seats are in the car are designed to deploy from a fixed points in relation to the front seats. filling the gaps between the driver and the front seat passenger pretty much wherever the seats are racked to. However, protecting rear seat passengers presented a far greater challenge. And so that's why they are working a lot on backseat as well. Yeah, you can see that this is just an animation that's showing that how perfectly a backseat is helping the drivers, the occupant to protect the occupants. And this is working perfectly well. And currently, few advanced vehicles industries such as Mercedes are working on this one. They already have it in the S-Class. And I hope that other ones that are going to do the same thing. So far, the Tesla does not have it, but hopefully in a few years, they're gonna bring that one as well.
Hello, everyone, and welcome
So
to an all
now let's listen to
of
one
the
interesting
S-Class
video that
Digital.
has lots
Now,
of
this is our
information,
second
video
special about
information.
what many consider to be the best car in the world. And today it's all about intelligence and innovation. And my guest to my left is Mercedes-Benz head of automated. Hello, everyone, and welcome to an all-new episode of Meet the S-Class Digital. Now, this is our second special about what many consider to be the best car in the world. And today it's all about intelligence and innovation. And my guest to my left is Mercedes-Benz head of automated driving, Michael Hoffman. Michael, thank you so much for joining us today.
It's a pleasure to meet you. Hi, Yasmin.
It's a pleasure to meet you as well. We're thrilled. And as I just mentioned, the S-Class is called the best car in the world by many automotive experts, surely for good reason. And one of them is definitely the pioneering safety features. So maybe you can start out by telling us a little bit about those.
I'm very happy to do so. It has always been in the DNA of Mercedes-Benz to concentrate on safety. We introduced many safety innovations to the world. Two examples. Nearly 40 years ago, we introduced the front airbag into our vehicles. And 25 years ago, it was the ESP system that was introduced by Mercedes-Benz. In the meantime, both innovations are available in nearly each car in the world.
So that's a very long, very proud history. And today you've brought along some new innovations. Why don't you tell us why we're standing here, Michael?
Well, we are looking at the rear seat airbag. And the rear seat airbag is another innovation, first ever in industry. We showed it last year in our experimental safety vehicle, right in that setup here. And that rear seat airbag takes into consideration very, very special situations in the rear of the vehicle.
And this speaks to one of the points that we established during our last episode of Meet the S-Class Digital, which is that you put a lot of focus on the rear seat passengers, also, of course, in terms of safety when it comes to your new flagship model, right?
We did, and we did for good reasons, because especially in the S-Class, the most important people often sit in the rear of the vehicle. Could be the boss, could be kids, and sometimes that's even the same person.
That could be the same person, definitely. So what is so special about these rear seat airbags?
Well, if you look at them, you see that it's not the complete cushion that is inflated by the gas as it is in the front airbag, but here it's only tubular structures that are inflated by the gas. And the rest of the structure is very flexible. It is used ambient air that is sucked into the airbag rather than gas, and that gives another flexibility into the system.
And when you feel it right here, you can tell it is indeed extremely flexible right here, very sturdy. So this is new also in terms of design. This is not what we're used to. What's so special about this design we're seeing here now?
Well, the specialty is the flexibility, and that is because in the rear of the vehicle, the spatial situations are quite different. You have adults sitting there, you have children, you have child seats in opposite directions or front directions, so totally different scenarios, and that's why we need a very, very flexible structure.
And when we listen to you explaining this, then of course we notice that there are so many factors that come into consideration during development and planning, right?
Absolutely. For example, where to put the airbag. This is why the engineers came up with a package that is easily packed into the rear of the front seat with a small gas volume. After the event, the gas is in the tubes, and once the tubes would encounter an obstacle or something, rather than just pushing and crashing into it, they can kind of wrap around it very flexibly. And that's why the whole structure adapts to the very situation of the crash.
Okay, very interesting video. Very good. So let's talk a little more about the seat belts. Well, actually, seat belts were first invented more than a century ago, around 1903. And then it became more and more popular. And then France was the first country that declared the mandatory of the use of seat belts in 1973. And then after that, after 2 years, the US followed by the rules to make it compulsory for everyone in 1975. And also, there are some advantages for the seatbelts. Seatbelts all has been one of the most significant cultural transformation in car industry in the United States and throughout the world during the last several decades. And only 15% of the individuals were seatbelt in the early 1980s. And that was pretty much interesting to know that these can improve the safety of the vehicles significantly. And historically, seatbelts use reduced the chance of traffic-related fatalities by 45%. And seatbelts minimize the body's contact with the interior of the car and resulting in fewer injuries. It basically spreads the force of the impact over a larger part of the body, reducing the severity of crashes. And it does all these things to decrease the severity as much as possible.
Everyone must wear a seatbelt.
Let's take a look at this video. It's very interesting.
And properly adjusted. You must buckle up for all trips in all seats. For seatbelts to work, they cannot be twisted. A twisted seatbelt won't spread the force of a crash across your body to protect you properly. Wear your seatbelt so that it crosses your chest and your lower hips. These areas of the body are better able to withstand the force of a crash. Drivers are responsible for ensuring anyone in the vehicle under the age of 16 is wearing a seatbelt or are secured in their appropriate child car seat or booster seat. Drivers can face a fine if they don't. If you're pregnant, you still need to wear a seatbelt. You should wear both the lap and shoulder belt and sit in as upright a position as possible. Wear the lap belt low so it pulls downward on your pelvic bones and not across your stomach. If you have front airbags, move your seat as far back from the dash as possible to reduce the potential impact of the airbag.
Very good. So there is another thing, part of this passive safety technologies is the crumble zone. Well, crumble zones are areas on the car that deform following a crash, creating a controlled crash. Therefore, the majority of the forces that may possibly affect the passengers are instead employed to crumple the car, resulting in a reduction in force acting on the occupants. And another technology is Buildbags. So Buildbags is pretty much a new technology compared to the previous technologies. And these are the things that combination of the seatbelt and airbags. In other words, it is an airbag fitted in the seatbelt. In case of a crash, the passenger, particularly the rib case, is subjected to significant force from the seatbelt. Well, I would say the aim of the Buildbags is to reduce the possibility danger to the rib cases. And you see that how it's gonna help the drivers. Just this video is showing it perfectly. Well, another thing is that electronic passengers protection systems. Well, these systems is basically designed to reduce the severity of injuries sustained to pedestrians when they crash with a moving vehicle. Well, basically, the pedestrian is protected from the heat generated in the engine's compartment. Some companies have been working on it very well. For example, Volvo has taken this technology a step further by integrating the passenger airbags. It also deployed an airbag As a result, it gives the pedestrian extra cushions, protecting them from injuries. And it specifically is protecting their heads, which is very important. Another thing is that, which is very important when it comes to the crashes, I mean, rear end crashes, is Wipeflash Protection. So this technology is meant to assist minimize the risk of whiplash injuries. When a rear end collision occurs, this technology is triggered to tailor the angle and speed of the crash, as well as the characteristics of the colliding vehicles. And you can see it here also, the ref. Okay, it's how it is gonna save the drivers specifically. That's pretty much very useful. And now let's take a look at about the child seat safeties. Well, there are a variety of kids' car seats in one of the most one of the most efficient ways to avoid this in the car crashes. Specifically, the children, you know, that they are very vulnerable. So we need to do our best to protect them. These technologies are a variety of kid safety seat belts available. For example, there are plenty of them producing here in different countries. And the usage of the seatbelt systems is to lap belt or a lap shoulder belt is one of these technologies. And so now let's take a look at this interesting video. It's very informative.
When you have a baby, a rear-facing car seat becomes one of the most important items in your life. A properly installed rear-facing car seat dramatically reduces the risk of injury in a crash. Infants and toddlers' heads are the heaviest parts of their bodies. They can't withstand a crash facing forward. A rear-facing seat will support your child's head, neck, and spine during a head-on collision. The seat helps spread the force of the crash across the back. This video was created by safety experts at Children's Hospital of Philadelphia. We want to make sure you install the seat correctly and that you buckle your child in correctly every single time. Let's get started. For babies, rear-facing only seats like these are one option. Never use them in the forward-facing position. It's not safe. Safety experts recommend that children ride in a rear-facing only car seat until they reach the maximum height or weight allowed by the seat. Find that information in your car seat manual now. Keep track of when your child outgrows the seat. Some families choose convertible car seats like these. A convertible seat is used rear-facing at first and then is turned forward when the child is older. For convertible seats, the manual will tell you at what height and weight to turn the seat around. Most children won't hit those limits until they're at least 2. Some states have laws requiring that children ride rear-facing until they are 2 or older. Google Governor's Highway Safety Association and Child Passenger Safety to find the law in your state. Now that you have a car seat, where do you fit it? That's easy, in the back. Secure the seat wherever you get the tightest fit. If possible, use the center of the back seat. Don't use the front seat. It's not safe for a variety of reasons, including frontal airbags, which can injure or kill a child. Let's move on to installing the car seat. You will need your vehicle owner's manual and car seat manual. First, make sure the seat is at the correct angle. Most seats have angle indicators. The car seat manual will tell you how to read your angle indicator. Many rear-facing seats also have an adjustable base to help set the angle. If your seat doesn't have an adjustable base, you may need to use a rolled-up towel or a swimming noodle to get the angle right. To strap the seat in, you can use the vehicle seat belt or the lower anchors of the latch system. Both methods are equally safe. Not every vehicle seating position has lower anchors. Check your vehicle owner's manual for more information. First, we're going to show you how to install the car seat using a seat belt. We're going to use a rear-facing only seat that has a lock-off mechanism that locks the seat belt. Pull the seat belt out and carefully thread it through the belt path of the car seat. Buckle the seat belt and make sure that it doesn't have any twists. To ensure a tight fit, press down on the car seat.
pull to tighten the seatbelt and close the lock off. Make sure it is tight. The car seat shouldn't move more than 1 inch in any direction at the belt pad. Now we're going to show you seatbelt installation using a convertible seat without a lock off. Pull the seatbelt out and carefully thread it through the rear-facing belt pad. Buckle the seatbelt and make sure it doesn't have any twists. Double-check the car seat manual to make sure you're using the rear-facing belt pad. Double-check the vehicle owner's manual on how to lock the seatbelt. In this car, you pull the seatbelt slowly all the way out of the retractor. This switches it to a locked mode. The seatbelt in your vehicle might be different. To ensure a tight fit, press down on the car seat and pull to tighten the seatbelt. To test the fit, hold the car seat at the belt pad and pull it from side to side, like this. The car seat shouldn't move more than 1 inch in any direction at the belt pad. If it does, press down again on the car seat and pull the seatbelt tight. Recheck the movement of the car seat until it moves no more than 1 inch. A loosely installed seat is one of the most common mistakes parents make. Your child is not safe in a loosely installed seat. If you choose lower anchors, check your vehicle owner's manual to find the latch seating positions. Next, find the lower anchors. Most vehicles have a small plastic button or fabric tag to help. The anchors are usually directly below the button or tag. In some cars, there won't be anchors for the center seat. It's okay to install the car seat in one of the side seats if that's where you get the tightest fit. You can also use lower anchors for a convertible seat. Attach each hook onto its own lower anchor. Tighten and adjust the straps according to the car seat instruction manual. Now, test the fit at the belt pad. The seat should not move more than 1 inch in any direction. Now, let's talk about strapping your child in. The harness straps should be threaded through the slots at or directly below your baby's shoulders. Now, buckle the harness. Next, buckle the harness retainer clip and position the clip at armpit level. This helps to keep the straps over the baby's shoulders. Next, tighten the harness. If you can pinch a fold at the shoulders, the straps are too loose. The harness should lie in a straight line with no slack. You can strap your baby in before you put the car seat into the base, like we're doing here. Or you can carry your baby and strap them into the seat after it's clipped into the base. Make sure your child wears light clothing every time they're in the car seat. Puffy jackets aren't safe. They create too much space between the baby and the harness. As your baby grows and you have a million things on your mind, it's easy to forget how important it is that the harness fits correctly. Make this a habit. Check the harness every time you strap your baby in and adjust as needed. You should also get in the habit of checking how tight the seat is as it can loosen over time. We hope you found this video useful.
Okay, very cute babies. Okay. Okay, so today we have learned lots of things about technologies. Let me just summarize and wrap it up. Basically, we have learned that there are lots of technologies that can help us not to get into a crash. The majority of them might be already available in each one of your car, or you may just would like to get familiar with them when if you want to have you purchase your new car, you may look at them twice and see that, okay, this is very useful for me and I would love to have that. And there are some technologies that if by any chance you get into a crash, they are going to save your lives or at least decrease the severity of it. So today we have learned about active safety technologies such as forward collision warnings and automatic emerging braking and lane departure warning system, different types of it, and all those blind spot detections, collision warning system, tire pressure monitoring, anti-lock, and just a few examples of them. And then also we have learned that there are some passive safety technologies such as the very famous ones that we are all familiar with: airbags, seatbelts, crumble zones, Buildbags, and electronic pedestrian protecting system, Wipeflash protections, and child safety seats. Overall, we have learned about around 25 active safety technologies and around 5 passive technologies. So now I would like to thank you for your participation, and now we are very open to any questions and any comment. And thank you so much for participating in this webinar. We hope that your knowledge has been expanded by this meeting. Now it's a time for our questions. If you have any question, please put them in the chat box and we would love to answer them. And also, would you please fill us our survey? So now we have just put it in this chat box. So if you can please, it's gonna take around less than 1 minute. If you can also please that survey, that would be greatly appreciated. If you can take it, you can do it, that would be very cool and we really appreciate it. Other than that, thank you very much. And now we are open to hear from you and we can read the questions. If you have any question, don't hesitate to put in the chat box. We are reading them for you. Okay. It seems that I don't see any question yet. I know that maybe a majority of you are filling the survey. Let's give it a few more minutes and we would love to hear from you. And then after this webinar, we're going to have, right now we are going to have a few minutes break. And then at 11, we are going to start another webinar. That in that webinar, we are going to talk about distracted driving technologies. That's gonna also be very informative and very interesting. Okay, maybe. Oh, okay. So one question I can read it is saying that, first of all, thank you so much for the question. The question is that Maryland just passed a law on rear-facing and child seat requirement for babies under 2 years old. Okay, good. Do we know what other states that already have this law are doing to educate drivers on this? This is a fantastic thing. I believe that there are some states that already passed some laws. At one point, we saw it in one of the videos, but exactly if I want to say it, I know that we are not the very first one, and we are not the only one actually. But I know there are some others say. But that's a fantastic question. That gives us a good hint that if we are ahead of the rest of them, but that's very good. I would take a note of it. Oh, some people. Okay, Mark, thank you very much. Mark is saying that Philly, DC, and Virginia, very good. Thank you, Mark. Beautiful. So, any more questions? Okay, okay. Thank you so much, everyone. So let's have a few minutes break, and then we will start the second webinar at 11. Okay, thank you very much, everyone. Let's just have a few minutes of break.